Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College for Women, Bhimavaram. In this lecture, we will discuss some problems on convolution sum. And let us solve some problems on convolution sum. Let x of n is taken as u of n, h of n is taken as of n, asked to calculate its response y of n. Consider an LTA system. The impulse response is h of n, and input to this LTA system is x of n. And corresponding output is y of n. Y of n is nothing but of n and h of n. This convolution is commutative. We can have x of n convolution to h of n or h of n convolution to x of n, both are same. So that equal to summation x of k h of n minus k. K is equal to minus infinity to plus infinity. In the same way, summation h of k x of n minus k. K is equal to minus infinity to plus infinity. If you observe, convolution involves 4 steps. One is time reversal. Second one is time shifting. Third one is multiplication. And fourth one is addition. So it depends upon our convenience. We have to keep one sequence constant. Second sequence, you have to take the mirror image, that is nothing but time reversal operation. Next step is you have to shift the sequence from minus infinity to plus infinity. Each and every stage you have to multiply both x of k and h of n minus k, or h of k and x of n minus k. Then finally you have to add to get one sample of y of n. So let us plot x of n and h of n. X of n is equal to u of n. So that u of n is the unit step function. Its value is 1 per n greater than or equal to, and its value is 0. So to plot this, 1, 2, 3. Value is 1. That its value is minus 1. Similarly, h of n is also equal to u of n. You draw h of n. And so on. This is formula. So y of n is equal to summation x of k h of n minus k. K is equal to minus infinity. So in order to get one value of output y of n, we have to multiply x of n minus k, you have to multiply x of k and h of n minus k for different values of n. Suppose if we substitute n equal to 0, then y of 0 will be equal to summation x of k h of minus k. So k is equal to minus infinity to plus infinity. The entire axis you have to multiply x of k and h of minus k, and multiply these two and sum over k, you will get one value of output y of n for n equal to 0. Similarly, by substituting different values for n, you have to get y of n values. So just rearranging these values in terms of x of k and h of k, so we will try to calculate output y of n. Let me plot x of k and h of n minus k. This is x of k. The same x of n I am plotting in terms of with respect to k. This is n, k, and this is 1, and its value is at minus 1, 0, at minus 2, 0. Similarly, h of k. This is h of, how to multiply x of k and h of minus k. H of minus k is the time reversal operation of h of k. This is 0, minus 1, minus 2, minus 3, minus 4. This is h of minus k. Just I am rearranging this equation h of n minus k or n equal to 0. Just I am trying to rearrange the axis value n comma k. This point indicates n. Okay, with respect to this n point, suppose I want to draw h of n minus k, h of n minus k for n less than 0. That means n will be somewhere here. N will be somewhere here. So this will be like this. This is h of n minus k. So coming to this, h of n minus k for n greater than 0. So n will be somewhere here. This is indicates the n value. So like this, we will be having impulses like this. So here we have to understand, as long as n is less than 0, n is less than 0, the overlap portion is from minus infinity to n. Okay, at n equal to 0, the overlap portion is from minus infinity to 0. At n greater than 0, the overlap portion is from 0 to minus infinity to n. Minus infinity to n. Or whatever may be the value of n, overlap portion always is from 0 to n, because we are convolving two causal sequences, both x of k and h of k available only for positive values of n. Okay, so you will be calculating y of n value as long as n is less than 0, output will be 0, because x of k is having sample values between 0 to infinity. 1, 2, 3. This is x of k. So h of n minus k, x of k must be multiplied with h of n minus k. So n minus k values, this value indicates n. This is h of n minus k for n is less than 0. So output y of n is equal to summation x of k, h of n minus k, multiplication between x of k and h of n minus k, for k is over this period, output is 0 as long as n is less than 0. The overlap portion starts only at n equal to 0. This is n equal to 0. This value is 1, overlap portion is at n equal to 0. This is the one. So at n equal to 0, so y of 0 is equal to summation x of k x of k and h of n minus k. So in n minus k, n value is 0. So I'm taking this is 0. Now this becomes x of k into h of minus k. So this is x of k, this is x of k, and this is h of minus k. Then we are multiplying one sample at n equal to 0 and one sample at k equal to 0. So output is 1. Only one sample will overlap. So coming to the n equal to 1, so y of 1 will be equal to summation x of k h of 1 minus k. By substituting k, n value is minus, n value is 1. So in this case, the sequence will move. This is the sequence. At n equal to 1, there is a sample. At n equal to 0, there is a sample. At n equal to minus 1, there is a sample. So this sequence will move towards right by 1 unit. So in this case, the overlap portion is from, so this sample will overlap with this sample, and this sample will overlap with this sample. So overlap portion is, so y of 1 will be equal to 1 plus 1, so you will get 2. Similarly, for n equal to 2, you will get one more sample. So y of 2 value becomes 1 plus 1 plus 1, you will get 3. And so on. As the n value increases, output increases. So final value what you will get is, y of n value is 0 as long as n less than 0. So as n increases, n is greater than or equal to 0. So this can be written as final output y of n. Y of n can be written as n into u of n. 1 into u of n, because at n equal to 0, its value is 1. Final output what you will get is ramp function. At n equal to 0, its value is 1, then 2, 3, 4, 5. So 0, 1, 2, 3, 4. 1, 2, 3, 4, and so on. So this is your final output y of n. So y of n can be written as r of n. Or we can say that n plus 1 into u of n. Let us consider another example. X of n equal to a power n u of n, and h of n equal to u of n. You are supposed to calculate y of n. Y of n equal to convolution between x of n and h of n. So here the a value is less than 1, in between both x of n are, this is the function of n is unit step function. This is nothing. Unit step function. Our sequence. So from this we have to calculate x of k function 0, 1, 2, 3. This is a power 0, a power 1, k square, a cube, and so on. This is unit step function. Of n is equal to summation x of k, h of n minus k, k equal to minus infinity to plus infinity. Then this is also equal to summation h of k, h of n minus k, because convolution is commutative. K is equal to minus infinity to plus infinity. So depends upon our convenience, we can keep either x of k constant or h of constant. And second signal, we have to take them in limit either to the impulse response or to this input sequence. For different values of n, we have to multiply both x of k and h of k. Let me draw this graph once again in terms of x of k and h of k. This is x of k. Okay, unit step function. Right, and so on, and so on. So you have to keep one signal constant, and keeping at present this is constant, x of k is constant. Second signal I am taking the measurement. This is the measurement of is h of n minus k n equal to 0. Similarly, this is for h of n minus k. This indicates n. This is h of n minus k for n less than 0. Similarly, for n greater than 0, this is the graph. This indicates n. This is for n greater than 0. This is 1. This is h of n minus k. So if you observe, for as long as n is 0, so y of n equal to 0 for n less than 0. So there will not be any overlap. So if you observe, this is n value is here, n value is here. So output is 0. So overlap portion starts from n equal to 0 onwards. At n equal to 0, y of 0 is nothing but only this sample is multiplied by this sample is multiplied by the sample present at n equal to 0. Okay, coming to the next one, for n greater than 0, the overlap portion is from, this will be somewhere here. The overlap portion is from, always the overlap portion is from 0 to n. So in that case, you have to write y of n is equal to summation. By multiplying x of k and h of n minus k, you will get a power k u of n minus k. K is equal to 0 to n here. This value is summation a power k. K is equal to 0 to n, and its value is 1. So if you simplify this, what you will get is 1 minus a power n plus 1 divided by 1 minus a. This is your final answer.